Muy buenos días, querida audiencia de InfoSecurity México y Latinoamérica. Con ustedes, Juan Manuel Rodríguez, director de InfoSecurity. Es un gusto para mí estar con ustedes nuevamente. Quiero agradecer a todos aquellos que se han hecho presentes a lo largo de estos meses y nos han acompañado en nuestra serie de webinars. Y bueno, hoy tenemos una sesión más en nuestro ya habitual web series cada 2 semanas, y hoy tenemos la oportunidad de hablar con una persona que a mi parecer es un gran experto y que hoy nos estará contando acerca de Disrupting Ransomware Attacks with Deception and Concealment, algo que definitivamente está atacando a todas las organizaciones, y conoceremos de primera mano cómo negar los accesos a los atacantes a nivel de explotación de cuentas y activos locales en las redes. Nuestro invitado de hoy, como les decía, un invitado de lujo, nos está acompañando Joseph Salazar. Él es Technical Marketing Engineer de Attivo Networks. Les cuento un poquito de Joseph. Él es un veterano profesional en seguridad de la información. Lleva más de 20 años de experiencia, tanto en la parte militar como en la parte civil. Es un mayor retirado de las reservas del Ejército de Estados Unidos, habiendo servido durante 22 años como agente de contrainteligencia, oficial de inteligencia militar y oficial de seguridad cibernética. Ha sido administrador de sistemas y seguridad CSIRT, analista, gerente de operaciones de seguridad e investigador forense, informático en carrera civil. Hoy mantiene las certificaciones vigentes de la CISSP, CEH y ENSE. Tiene también una licenciatura en estudios legales de la Universidad de California en Berkeley, y actualmente, como mencioné, trabaja para Attivo Networks como técnico ingeniero de marketing. Como ven, un experto que nos va a estar compartiendo hoy durante estos 45 minutos cómo poder prevenir estos ataques de ransomware. Joseph, welcome to InfoSecurity Mexico. Thank you so much for joining us to this web series, and we're very thrilled that to learn everything that you have to share with us. So welcome.
Thank you very much for having me.
It's a pleasure. So please, let's go to the chase. So let's start it.
All right, let's go ahead and get started then. So hopefully you can see my screen. Is that correct?
Yes.
Perfect. All right. So as you said, this talk is on disrupting ransomware attacks with deception and concealment. This is the agenda that we'll be covering. It's very straightforward. Hopefully it'll be easy to follow. A little bit about me. You gave a good summary of what I've done, but what it comes down to is that I've done information security for a very long time, both in the military and in the civilian public sector. And I've taken a lot of this experience and brought it to Attivo Networks in a non-practitioner position, which is the first I've ever done. So let's talk a little bit about the ransomware problem and how bad it actually is. So here's some interesting statistics from last year. A ransomware happened every 14 seconds. The most targeted regions were the US and the Middle East, Turkey, and Africa regions, but it is clearly a global issue that grows worse each day. The average payout was $111,000 US, with recovery costs almost triple that. Many victims were hit with double extortion, where the attackers would threaten to release stolen data unless they received further payments. Between 50 and 70% of victims chose to pay, so clearly ransomware is effective. Researchers identified over 200 different strains last year. They also saw a shift where attackers targeted businesses instead of consumers. These attacks were customized to impact a specific target instead of trying for mass infection. By far, the most devastating statistic, 71% of targeted companies got infected. So if an attacker put you in their target, you got infected 71% of the time. So here's a quick snapshot of the various ransomware variants identified in the link below, which is a searchable reference guide. Now, researchers saw a rise in the number of ransomware 2.0 attacks, which are human-driven to target sensitive or critical data and assets. The focus was compromising target networks to go after the high-value targets. The attackers would exfiltrate the data and then encrypt it for double extortion or threaten to release it to extract a higher ransom. According to the Mandiant Security Effectiveness Report, 60% of organizations did not prevent or detect a ransomware detonation during testing, and only 7% alerted on the activity. So why is ransomware so effective? Because it's easy. It is simple to execute. You just have to get ransomware onto the system to infect the initial endpoint, and then they will locally exploit the files. It'll encrypt any local files, folders, and any attached shares or storage. And then it's going to laterally propagate, compromise all those systems that it moves to, conduct reconnaissance, steal credentials, and spread laterally. Now, ransomware 2.0 attacks will also target those high-value assets such as Active Directory or critical file servers or your web server to steal and encrypt data for ransom because they can get more of a payout. So why are ransomware attacks, particularly ransomware 2.0 variants, so hard to detect? Well, organizations can't account for all the egress points out of their network at every moment, so you can't stop data exfiltration. Attackers use advanced tactics to move laterally and access data. Now, these tactics are common to more sophisticated APT actors. As we saw with the Mandiant report, existing security controls don't always detect ransomware or alert when it happens. And finally, what makes ransomware 2.0 attackers different is that they wait until they've successfully compromised many systems and encrypted the critical data before they actually let you know that they have you under ransom. So Microsoft created this table to show attack techniques from several different ransomware threat actors. Notice how they use different tactics across stages of the attack: the initial access, the credential theft, lateral movement, persistence, and then the payload is different. But they also target different vulnerabilities to successfully conduct their attacks. For example, Robinhood uses weak application settings, then runs Mimikatz to steal credentials, uses they use RDP brute force, then they steal credentials in plain text, they use lateral movement via WMI, and then they create new accounts for persistence. Whereas something like Maze, who also uses RDP brute force, uses Mimikatz to extract credentials, uses Cobalt Strike beacons for their lateral movement, and then make changes to GPO to drop their payload. But there are consistent stages within these attackers. So here's an example of a recent ransomware 2.0 attack that illustrates how quickly it can happen. The initial access came from a phishing email containing links to Google Drive that downloaded a bizarre loader backdoor executable when a user clicked on it. The time from the initial bizarre execution to domain reconnaissance was 5 minutes, and deployment of Cobalt Strike beacons was within 10 minutes. After bringing in Cobalt Strike, the attackers used AdFind, which is an Active Directory query tool, to continue domain discovery activity. Now, in this case, they deployed persistence on the beachhead host. After establishing another command and control communication for additional Cobalt Strike beacons, they employed the zero logon exploit, which is CVE 2020-1472, and obtained domain administrative level privileges. They also used host process injection on the beachhead for obfuscation and privilege escalation. Now, with domain administrative privileges obtained, the threat actors then moved laterally throughout the network using server message block SMB and remote desktop RDP to deploy Cobalt Strike beacons on the domain controllers around 1 hour after the initial execution of the Bazaar loader. On the domain controllers, some additional discovery was done using PowerShell Active Directory modules. From there, they targeted other servers in the environment, specifically the backup systems, file servers, and software deployment servers. Now, after establishing Cobalt Strike beacons on those, they then went to their final objective. At the 2-hour mark, the threat actors made the move to deploy the Ryuk ransomware by establishing RDP connections from the domain controllers to those critical servers. This continued for the next hour until the entire domain had been encrypted. And then once they finished that, 3 hours after the Bazaar loader was executed, they sent their ransom. So here's the noteworthy tactics that the attackers used. Privilege escalation, credential access, discovery both at the domain and within Active Directory, and then lateral movement. Now, interestingly, Attivo networks can detect and prevent these activities using its deception and concealment technologies to limit the ransomware attack's ability to move laterally early in the ransomware attack cycle. So, any place that you see a red box, you could detect them with deception and concealment. So what exactly is deception and concealment, and how can it limit the damage that a ransomware attack can cause? Well, let's review that ransomware attack cycle. The first stage is initial access, and organizations rely on their endpoint protection platforms and their endpoint detection and response to prevent and detect the attack. So your EPP and EDR work at this initial access level. Now, if the attackers evade those controls, once inside, the attackers will steal credentials using many different tactics, as you saw in that Microsoft graph. Again, the organization is relying on their EDR to detect this activity. The attackers will then spread laterally to find and infect their high-value targets using many different techniques. The further from the early stage of the attack, the less effective EDR actually becomes at stopping it, and the more damage the ransomware can cause. Now, they'll also establish persistence so they can come back and continue their attacks. Again, there's many different tactics that they can use to do this. Now, Attivo addresses many of the tactics in these stages of the attack, from credential theft, lateral movement, and privilege escalation. The goal here is not to replace EDR. The goal is to work with the EDR solution to provide more detection and protection coverage against the ransomware attack throughout the entire ransomware attack chain. So a little bit about the platform before we continue. Starting at the bottom, you have the AD Secure module, which is available as a standalone product for organizations who want to just protect their Active Directory. Next is the Endpoint Detection Net, or EDN suite of products, which includes AD Secure and a few other components to detect credential theft and prevent lateral movement. And then finally, we have the Asset Defense, which is handled by the BotSync server, and that has attack detection, decoy engagement, and threat intelligence development and collection. So starting from the very bottom and expanding all the way up, you can get a full deception and concealment fabric to detect all types of lateral movement anywhere inside the network or in the cloud. So the platform addresses the minor attack phases of discovery, privilege escalation, lateral movement, and collection. It provides attack path visibility to limit the attack surface. Concealment hides and denies access to sensitive or critical objects, and I'll explain that later. Fake data misdirects and detects lateral movement attacks. And then network and cloud decoys obfuscate the attack surface and collect threat intelligence when attackers engage with them. Now, this includes creating decoy file servers, Active Directory servers, and many other functions. So what does concealment technology do? Concealment technology hides and denies access to local files, folders, network or cloud shares, removable storage, credentials, and Active Directory objects to prevent attackers from accessing, encrypting, or using them as part of the attack. Now, the EDN data cloak component provides some of this function. Attackers and ransomware can't see or access the concealed objects to exploit or encrypt them. Imagine if an attacker gets on your endpoint and can't see your user directory, the Windows directory, any backup directories, any Active Directory, stored credentials, or the administrative account. The solution will detect an alert on any activities that try to touch these concealed objects and then collect threat intelligence on their activities. Now, the next thing attackers will do as part of their lateral movement is conduct port scans from the beachhead system to any host they identify, looking for available services and then checking to see if they can exploit these services through vulnerabilities or misconfigurations. Now, because they are interrogating all the numbered ports from several hundred to the full 65,000 plus available, they're going to hit closed ports that don't have any running services. Now, the EDN deflect function redirects any connections, even ICMP ping, that touches these closed ports to a black hole port or a decoy with a corresponding open port and service. Now, this deflection does two things. It prevents accurate fingerprinting because even closed ports will respond, so the attacker can't tell whether a port is truly closed or actually open. And it redirects the attacks away from the production assets, further disrupting the attack both on the inbound connection attempt. So, for example, if an attacker tries to connect via HTTPS and SSH to a system, and the system only has SSH, it's going to allow that connection through, but forward the HTTP traffic to the black hole port or a decoy. It also does so on the outbound. So if a protected system has an attacker on it and he attempts to do these activities, the same result will happen. He'll connect to the SSH port on that server, but the HTTP port will get forwarded to a black hole or a decoy. And because it can handle both inbound and outbound, we get the added functionality of isolating using native quarantine functions by redirecting both inbound and outbound communications from that attacker to the decoy or a black hole environment. So there is no way that attacker from that endpoint can communicate with the production assets. Now, attackers will query Active Directory to collect information to use in their attacks. Any domain joined system can query Active Directory, and no current security controls can identify an illicit query from a legitimate one, except for the AD Secure solution. Now, regular users do not query AD as part of the regular job functions. And privileged users that do so are part of specific security groups that authorize them to make these queries. The AD Secure solution looks for unauthorized AD queries where either the user or the process is not part of its access control list. It detects these illicit outbound queries and hides any sensitive or critical accounts and objects that come back within all the results. And it inserts decoy accounts and objects in their place. Now, the best part is this all happens at the endpoint. The solution does not affect Active Directory production controllers at all. You do not have to touch the production Active Directory controllers because you're deploying these at your endpoints. Now, again, these can point to a black hole IP address or a decoy for engagement. And I'll show this activity and I'll show you how this works during the demo. Now, the graphic below is an example of how attackers can compromise Active Directory to further their attack. They're going to gain an initial foothold, typically using social engineering, such as a phishing email, much like those attackers did in that case study I showed you with Ryuk. They got onto a system using social engineering, and user clicked on a bad link and downloaded the bizarre loader. Then they're going to conduct reconnaissance and discovery. They're going to look for privileged users. They're going to look for a user that has any types of privileges, such as administrator, service accounts, anyone that is available on an access control list. They're going to check what are called net sessions. Net sessions are any sessions that are open and currently connected to Active Directory. They're going to do this to look for high-value targets, such as domain controllers, your CI/CD infrastructure for anyone that's using your continuous development, continuous integration, with something like Jenkins servers, anything that is a high-value asset. And then they're going to also look for high-privilege users like administrators, going to look for paths that connect to them using groups or stored credentials. Then they're going to move laterally to the domain admin's PC using common local admin passwords or hashes, or breaking in with something like Mimikatz or any other credential harvesting techniques they have. Because that domain administrator's PC has a direct access to the domain controller. So using that access, they're going to steal the domain administrator credentials, whether it's a saved credential, an RDP session, connection to a CIF share, anything like that, and connect to the Active Directory. Well, they will then create a persistence on the Active Directory by creating new domain admin accounts or finding accounts they can elevate to domain administrator. This is where you're going to see things in the audit logs like a password change or an account lockout, or of a service account suddenly going active, or a deactivated account being activated, or a new account creation. And then from there, they're going to go after the high-value targets, whether it's a database or a file server, or that executive's PC, so they can steal confidential information or business plans or anything like that. Here's the interesting part. If you disrupt their recon and discovery, you disrupt everything else downstream. If the attacker can't gather accurate evidence, intelligence, you as a defender can derail their attack because they're working on actual intelligence that is fake, that is false, that will mislead them away from production assets and where you want them to go, into the decoy and deception environment. So how does the Threat Defend platform actually reduce ransomware risk? Now, this is an example of a ransomware 1.0 traditional ransomware attack. The risk is to data loss and lateral propagation. Attivo has a unique solution for ransomware that will actually stall the attack and slow it down so the defenders can respond quickly. When ransomware infects a system, it's going to look for the local folders to encrypt before moving on to the network shares. The EDN solution addresses these actions with decoy credentials, hidden fake mapped shares, which I'm going to show you, and the data cloak function that hides these local files and folders so the ransomware can only see the decoy file shares. When the ransomware spreads to the decoy file shares, the solution rate limits the connection, so it slows it down, and then it begins to feed the ransomware with unlimited fake data. It's just going to keep feeding it data so it never completes its encryption process, and thus it stalls the attack. Imagine if ransomware starts encrypting a file, and behind that file, the system is just feeding it more data, like piping dev random to it, so that the ransomware just keeps encrypting that file, and that file just keeps getting larger and larger. Now, the cool thing is that it also alerts the security team so they can know that a ransomware attack is happening and they can respond to it quickly. Now, this may be sufficient for traditional ransomware attacks, but what about ransomware 2.0? Well, recall that ransomware 2.0 conducts lateral movement activities similar to an advanced attacker, which is what the Attivo solution already addresses. So it will effectively derail ransomware 2.0 attacks as well. So the ransomware is going to infect the system, and then it's going to try to conduct Active Directory reconnaissance to discover those crown jewels. The AD Secure solution is going to disrupt that AD recon by hiding the real production objects within Active Directory and inserting fake production assets and objects in its place. So the solution is going to deceive the recon and thus prevent the lateral movement activity, because the lateral movement is going to end up on the decoys, not on the real production assets. And then the platform is going to alert on the activity. So as the ransomware attacker tries to move laterally using many of the techniques we've already discussed, the Attivo solution is going to detect the activity, derail it, and misdirect it to the deception environment for you to do with whatever you want. You can observe the activity, you can collect threat intelligence on it, you can stop the attacker from continuing their attack, and then you can kick them out of the network. So let's see this in action. So what I have here are two systems. They're both part of the same Active Directory environment, and they are both logged in as the same user. Now, just to save time, I'm going to run this batch file. Now, this batch file just runs a set of standard built-in commands that an attacker would do to conduct Active Directory recon and a few other things to do discovery and identify things. Now, as a ransomware attacker, I'm going to be using a lot of these techniques. Notice there, all I'm doing is running the commands. There are no canned results. Now, both batch files are the same. There's just a few minor differences, because here's the thing. The system on the left with the purple background is unprotected. The system on the right is protected by the Attivo solutions. So they are part of the same Active Directory. They are logged in as the same user. If I run these commands, I should get the exact same output. But you're going to see the differences where the protected system is showing something different from the unprotected system. So let's go ahead and get started. So the NL test is a built-in utility in every single Windows system. What it does is it will query Active Directory. Now, the DC list function is going to list all of the production Active Directory domain controllers. Notice on the left, I've got 5 domain controllers that I'm seeing, with the primary domain controller being ad.sedemo.sedemo.local. Notice on the protected system, I've got 2 completely different results. I've got mar win server 2, which is the primary domain controller, and mar win server 1. These should be the same results, but because the system is protected with the AD Secure solution, it's sending the attacker down the wrong path. Now, the ds-get-dc flag for NL test tells me which domain controller I'm connected to. I will assume that this should be the primary domain controller, and it is. Now, if everything is consistent, I should also see the primary domain controller on the protected system, which in this case is mar win server 2. So the attacker is getting the expected result from their query. Now, I'm going to enumerate all of the domain administrators that belong to that group, net group domain admins. Now, in this case, you see I have 10 users, or I have more than 10, I'm sorry. I have 21 users that are part of the domain admin group. Now, here on the protected system, I have a bunch of threat actors, not threat actors. Now, clearly, Brad Pitt, Johnny Depp, Scarlett Johansson, and Will Smith do not work for Attivo networks. But I'm listing them here. And notice I have 11, and Mark is just another one that's fallen in there. So I'm showing fake user accounts and 1 real account. Notice that Mark belongs to both. Now, I want to verify that one of these users is real. So I'm going to check Amy Gully in the unprotected system, and notice the type of information I get. The last password set, last login, and the group memberships. Now, if I run the same command on the protected system on Brad Pitt, I should expect to see similar information. And I do. Notice the data is different. The groups that he belongs to are different. The last login is different, even when they last set their passwords. But it's the same type of information. So it is consistent. An attacker running this is seeing what they are expecting to see, but the data is fake. Now, setSPN. The setSPN command, or the set service principal name command, is a command in Active Directory. A service principal name is how Active Directory knows to allow a server to validate with a service account. You set a service principal name so the Active Directory controller knows that you as a server is authorizing a service account to validate for you or on you. The setSPN command sets this. The -q flag is a query. So in this case, what we're doing is we're querying service principal names for all HTTPS servers, so secure servers. So as an attacker, I'm going to look for secure servers because they're a high-profile target. They're a high-value target. I know that if a web server has HTTPS, that it is holding sensitive data that needs to be encrypted in transit. So when I run this command, I see 5 different servers. I have some code repositories, I have some CRM servers, and I have an SAP web server. If I run that exact same command on the protected system, instead I get 1, and that 1 is our fake server, WinServe2. And that WinServe2 is running HTTPS and SMB and a few other things. Now, just to test to make sure that these servers are actually real, I'm going to ping them. So you see that I'm pinging mar WinServer1. Now, mar WinServer1 is a decoy with an IP address, so I'm getting a reply. I'm also going to ping our domain controller. Notice I am getting a reply from our domain controller as well. So as an attacker, if I try to connect this via IP or via name, I'm going to land on a decoy. Now, the klist command lists all Kerberos tickets that are currently cached in memory. Kerberos tickets are how systems validate to the Active Directory domain controller. As an attacker, I can steal a Kerberos tickets and use them for subsequent attacks like Kerberosting, golden ticket attacks, or silver ticket attacks. Now, in this case, I'm going to run the klist command to see what Kerberos tickets are cached in memory on the unprotected system. Notice that there are 5 because computers always start counting from 0. Notice the server is the Kerberos ticket granting ticket is sedemo.local, and the Kerberos domain controller is the primary domain controller. This is consistent across all of these systems. The primary domain controller is the KDC. Now, if I run that exact same command with the protected system, I see 5 cached domain controllers, 5 cached Kerberos tickets, and they all point to my decoy domain controller. So they're consistent, again, across all of these tickets. I know that this is my primary domain controller because that's the KDC. Now, as an attacker, I'm going to want to know who is a local administrator. Again, that's part of the privilege escalation activities that I'm going to do. So I'm going to check to see who's a member of the local groups. Notice that I have 5 domain controllers, 5 local administrators in the unprotected system. And there's another way you can see this. If you pull up the file server, the file manager, and go in and manage the PC, you're going to see, I'll do that with the main system as well. You're going to see this computer management snap-in. Under the local users and groups, if I go into the group, under administrators, I see the same users that I got with this output. So if I look at who these domain administrators are, they match. Now, if I run that exact same command here, I should get the exact same result because, again, this is all part of the same Active Directory. They're all part of the same domain. They should have the same local administrators. But in this case, I'm only showing 2, the decoy admin and the sedemo local domain admins. What I actually have is different. I'm going to show you, this is the data cloak function in action. I'm going to show you who's actually a member of this local domain group, local administrator group. Notice the differences in the responses. Here, I only have 2. Here, I have multiple. I hid administrator, Chandan, demo user, and sedemo Joseph. All the attacker is seeing is sedemo admins and the decoy admin local. Now, why is this the case? This is the case because the data cloak function, the way it works is it looks for authorized processes that will allow that, and it will show the right result to the authorized processes. Most attackers do not have graphical user access to the system. They're going to be either using something like Netcat or reverse shell or remote shell to run commands in command line to the system that they're attacking. So when you're running on command line, because I configured this system to not show accurate information on command line queries, it's showing all of the attacker fake data. All of the queries the attacker is running are getting fake data. But the regular user who's going to use the graphical user interface is going to see the real data. So let me cancel this and get back to the file manager, because this next part is really interesting. The net use command is going to list all of the network mapped shares on a system. In this case, I have the X drive. Now, the X drive is here. So I know that this drive is real. However, when I run the same command, I get a W and a Z drive. Now, that W and Z drive are decoys, and I know this because I know that Marwin Server 2 and Marwin Server 1 are decoy systems. However, notice that I actually have an X drive that the data cloak function is hiding from the attacker. So as an attacker, if I enumerate this system with net use function, because I'm trying to do a ransomware attack, I'm not going to see the production file share. I'm only going to see the fake file shares. Now I can actually go to those if I CD to them. So for example, I'm in, all right. So I, as an attacker, am only seeing the fake file shares. Now, what I'm going to do next, I'm going to show you the deflect function, right? So as an attacker, if I do manage to get on, I'm going to want to try to move around, particularly if I'm a ransomware attacker, because I want to see if I can move around. Now, netstat-an shows you all of the available ports that are listening on this system. If I run the exact same command here, this is the protected system. Notice I get the same results. I get 135.445.339. Those are standard Windows ports. And then I get a bunch of high ports, right, which are just usual, normal, they're random ports. Now, as an attacker, I'm going to try to look for specific types of ports, but I won't see these ports because I don't know what's available. So I'm going to interrogate them. I'm going to ping, I'm going to try to connect or whatever. So if I were to, say, load a web browser and try to connect to 192.168.5.23, I should not get any connection because there's no web server listening. Notice there's no port 80 or port 22 or anything like that on this system. So if I open this, I should not get anything, but I get something. I get a fake login page to my ADP, which is a payroll function. What if I tried to do Brad Pitt and I try to brute force it? Let's see if I can overrun the buffer. I get in. I'm actually inside the fake web server that I should not have connected to because this system doesn't have port 80 running. What the system did was it deflected the connection attempt to a fake web server that has information. And look at the dates. This is updating regularly. So I'm going to think this is an actual production web server. Okay, so that's inbound. What about outbound? Let's say from this protected system, I'm going to try to connect to .130, which is this system, this unprotected system. Now, .130 does not have port 22 open. There's no SSH server there. So if I connect, I should not get anything, but I do. Let's try to connect as Brad Pitt. I get in. Notice the operating system is CentOS, but this is a Windows system. So outbound, I deflected that connection attempt. Now, let's try some discovery. Now, just to confirm, I am sedemo.userx. Now, I'm going to see what's in the users directory under user X, right? Because I know that as an attacker, I'm going to look to see what that user profile is and what it contains, because then I can encrypt it. So let's do the same thing here. Now, if I enumerate this, you see regular stuff, and that's going to match everything that I have in the users directory under user X, right? This matches. Let me scroll this up, and you can compare. It matches. Now, if I run the exact same command here, notice that I get similar results, right? I mean, a lot of that stuff is similar. However, if I go into my user directory, notice I have a hide me folder that is not showing up. That's DataCloak in action. I actually created this hide me folder and configured it so that DataCloak would hide it from the attacker. Now, there's stuff in here. This is actually a folder that I can go and I can write information into, and I can save. But as an attacker, if I try to go to hide me, it won't let me do it. What if I try to delete it? Yeah. Hey, oops. It's what is it? RMDIR. And files. So they can't get anything. If I had stuff in hide me, they couldn't access it. They couldn't enumerate it. They couldn't encrypt it. But I know some place where where there's always stuff. What about the documents folder? So let's see what's in the documents folder in the real directory. Notice here I've got a bunch of stuff, right? Oh, that's the desktop. Sorry. Go up. Documents. So here I've got a bunch of things. I've got a PDF file, I've got a document, I've got a PowerPoint, I've got a spreadsheet, I've got a text file, and I've got an image. But when I enumerate it, all I see is a text file and the image. That's because when I configured DataCloak, I made sure to hide all Office level documents, so the attacker can't access them, because to me, they're more important than a text file or a picture. So that is DataCloak in action. And that concludes the demo. So let me switch over back to the slides. Now, a little bit about Attivo. We have really strong customer traction of over 300 customers globally. We have half of the Fortune 10. However, 65% of our customers have less than 5,000 employees, showing that we can scale from the mid-sized enterprises all the way up to the big organizations. We've got tremendous growth. The company has over 200 employees globally. We showed up for 3 years in a row. This is our third year on the Deloitte Fast 500 list, and that represents 724% growth over the evaluated period. We've won over 130 awards and counting. We are well-funded, ability to execute. We were actually profitable over the past several quarters, and we are the expert in preventing and detecting lateral movement and privilege escalation. We specialize in protecting identities, credentials, and high-value assets anywhere your enterprise exists, at the endpoint, within Active Directory, and in the cloud. So thank you very much. I appreciate that. For all of you listening to me. Are there any questions?
Thank you. Thank you so much, Joseph. It was an incredible session, very, very constructive and enlightening, to be honest. And yeah, a nuestra audiencia, recuerden, estamos en vivo, háganos llegar todas sus preguntas. Aprovechemos, tenemos unos minutos más con este gran experto. Joseph, we have a couple of questions here on our platform. So I will go from the first one. Do you know cases about ransom attacks to individuals, not companies, not organizations, but to persons?
Yes, so there are attacks that still happen and still target individuals. Those are the ransomware 1.0. There are several instances of attackers going after and targeting a specific individual for ransom, but generally those are going to be high-profile attacks or high-profile people. I am familiar, however, for an attacker to get a lot of money from a ransomware attack, they're going to target multiple individuals, not just one, because there's not a lot of money in that, or they're going to target critical individuals in big organizations. So, for example, if I were to successfully encrypt a person's laptop and they have a backup, that I'm not going to get a ransom out of that. But if I were to encrypt a company's Active Directory, I'm going to get a big ransom out of that. We've actually seen that happen several times. There was a big ransomware attack, I don't know if you saw, with the University of San Francisco, where their Active Directory was encrypted, and they paid over $1 million to ransom that Active Directory. So yes, ransomware attacks do target individuals, but more money is made targeting large organizations.
Okay, I think we lost your on camera, but as
There we
long as
go.
that now you're back. Okay. What else we have here? We how to be prepared this year in cyber attacks issues. What's your recommendation?
So I would recommend, I mean, besides looking at and making sure that you're always patched, making sure that you've got your good security controls and they're tuned properly, that you've got a SIM that's tuned properly, I would suggest deploying new technologies, because this year is the year you're going to see a lot of lateral movement activity, particularly because of SolarWinds. A lot of organizations are potentially vulnerable to the SolarWinds breach. And you saw within SolarWinds that attackers are getting in and they're moving around laterally. So if you want to be prepared for a cyber attack this year, you need a solution that can detect and stop lateral movement. Now, yes, Attivo does do that, but there are other solutions, or you can homebrew your own, and you can look in those. You can look at those. But I would honestly recommend looking at ways to stop lateral movement, credential theft, this internal discovery, all of those things that an attacker would do to move around inside your network, because that's where the danger lies. Because once they get in, it is very difficult to detect them.
Okay. This goes, I mean, we have a very similar question about the big threats that we will face this year.
Yeah, I would say it is really more about ransomware. It's not, well, ransomware is going to be a big part, but it's really more about the lateral movement, right? So yeah, I would suggest, I mean, that's probably going to be one of your biggest threats, is attackers going after you and then moving around laterally, because you're not going to stop an attacker from getting in. It's not a matter of if, it's a matter of when. They've proven time and again that they can bypass or evade your prevention controls, and they can evade detection once they get inside. So that is the big threat.
And with this new normal, where everybody is working from home or doing remotely work, have you seen any increase on that type of attacks?
Yes, and particularly for if you're a remote worker, right? You're either doing VPN or you're doing cloud, right? Now,
Yeah.
VPN is very interesting, because if you're on a VPN segment, it's very difficult to identify an attacker on the VPN segment. And the reason why I say that is because all attack activity is going to appear to be coming from the VPN concentrator. It's very hard to trace that activity. If an attacker compromises a home user, uses that access to get through VPN, and then enumerate Active Directory from inside the VPN concentrator, from the VPN segment. That's going to be very difficult for you to do. So yes, we have seen an uptick in that. Our customers have actually deployed us within the VPN, and they have discovered attackers that are trying to do that. If you're going to attack the cloud, then you're going to have to find ways to protect your cloud credentials and your cloud infrastructure. Yes, we operate in the cloud. Yes, we can do things like that. But there are other solutions you should do. You should do CASB. You should do CWPP. You should do CSPM. And then Gartner has a new quadrant, or not quadrant, a new category of security controls called CIEM, CIEM, Cloud Infrastructure or Identity and Entitlement Management. So that is all about managing the entitlements within the cloud. So you should be, as a remote worker, or if you have an organization with remote workers, you should be looking at ways to really protect those two things: your remote access and your externally stored data and externally stored services via cloud.
Perfect. Talking about Attivo, how does the Attivo concealment function really works?
So the concealment function works by actually it looks at specific users and processes. So if a user is not authorized or a process is not authorized, it's going to hide things from them. So that's the really cool part. The mechanics of it are a little bit hard to explain, but essentially what we do is we install a DLL and several small scripts running on the endpoint. You can call it an agent, but it's not really, because it's only looking for API access on a few things, and it's looking for specific types of enumerations. And then what it does is it looks for those unauthorized users or unauthorized processes. So if an attacker installs a process, compromises a valid user, but installs something like Bloodhound to query Active Directory or AdFind and Bloodhound are not going to get real results, because even though the user is authorized, the process is not. So that's how the concealment function works.
Okay. Somebody says here, if I already have a EDR to stop ransomware, why should I need an Attivo technology or this type of technology?
So that's a good question. EDR does a very good job at identifying things that are happening at the endpoint, right? So EPP is meant to stop an infection. EDR, for the most part, will also do some of that. But what it's really designed to do is it's designed to give you that visibility at the endpoint for processes and activities that indicate an infection or a compromise, and then allows you to either isolate that endpoint or conduct additional investigations on it. What Attivo does is somewhat different. There's a little bit of an overlap, but it's different in that we're not looking at the endpoint itself. Now, EDR is not going to identify bad AD queries, but Attivo will. So think of it as adding to the detections that you get from the EDR solution on the endpoint. So it's not about replacing EDR with something like EDN or AD Secure. It's about using the two together to get more coverage. EDR is very good at what it does, but what it does, if you look at it from a MITRE ATT&CK framework perspective, it looks at the first 5 stages, the initial infection. But if the attacker does evade detection and prevention and gets on and infects that system, Attivo looks at the next things they're going to do, which is the lateral movement stuff. It's going to be the discovery, lateral movement, privilege escalation, and data collection activities. So rather than getting just coverage for the first 5, if you use EDR with Attivo solutions, you're getting coverage for the full 8. And then beyond that, when they're doing the exfiltration and compromising, there's a few things that we do there, but that's where DLP really shines, is at the back end of that MITRE ATT&CK framework. So if you use EDR for the beginning, you use Attivo for the middle, and you use DLP or something like it for the end, you're going to have a better security solution for across the entire MITRE ATT&CK framework.
Okay. Oh, wow. Definitely, we should have a complex environment and complement solutions. Here, we have 2 additional questions. Attivo can be integrate as a single sign-on, SIEM, IPS firewalls, can be hardening Windows systems and another software system of operations like what is that?
Android or Linux?
With Linux and so many others.
So yes, we do have integrations. We actually have over 40 different integration partners, and if you don't mind, I can actually show you a slide of all of the partners that we have. I have actually, let me just pull it up and share it very quickly. One moment. But yes, we do integrate with SIM vendors. We integrate with, here, let me share my screen very quickly. So hopefully you can see that.
Yeah.
Do you see the integration slide?
The questions slide, yeah.
Oh, okay. Hold on. Let me switch over to this one. How about this one?
Yeah. Now you have the partner integrations.
Yeah. So these are our native partner integrations. We have many different integrations, and some of them they integrate with us. So these are all the partners that we integrate with. For the SIM, notice we do have a lot of SIM integrations underneath the investigate, analysis, and hunting. However, we can send data to any SIM via syslog. These are the ones that we just happen to have an integration with, where we can do bidirectional communications. So let me stop sharing here. Now the other part, do we have can we do other operating systems? Yes, we can do Windows, we can do Linux, we can do Unix type systems, we can also do Mac. We can create decoys for things like Android, iPhone. We can even create substation decoys and things like that. But because mobile doesn't necessarily have most mobile attacks that target mobile devices are targeting the data within the mobile. They're not looking to spread inside the network. So we don't cover things like Android and iPhone, but we do cover all the major operating systems from a desktop perspective. We also cover all the cloud environments, every major cloud environment. and we do all types of different networks.
Okay, that's very good to know. You have everything covered. Last two questions. We have 5 minutes left. So, how can we detect the attackers, and how can they be reported to international organisms, like to obtain, I don't know, like legal proceedings
Legal
against
proceedings.
them, or
Yeah, that's difficult because so I used to do pen testing and red teaming, and I always proxied, and I would always proxy through 5 or 6 different proxies before I got any place. So identifying an attacker's specific location is difficult. However, we do have a function called a decoy doc. A decoy doc is a function where that is something that where we embed a tracking beacon into a decoy document, a fake document. And if that document gets exfiltrated and the attacker opens it, we will send the externally facing IP address and the GeoIP location of that attacker. However, for you to do legal proceeding on a specific person, you must have multiple different ways to identify them. We would just be one component. And because attackers use proxies and will tunnel through multiple different proxies, it is very difficult to identify that attacker unless you have a very complex intelligence gathering operation of some sort, or you're working multinationally with a bunch of different law enforcement organizations like Interpol, FBI, and things like that. So that's a very difficult question to answer. I mean, I have information in terms of how you could do it, but to actually get it done, because attackers tunnel through and proxy through a lot of different services, it's very difficult.
Yeah, and definitely we need to work and collaborate from everywhere. Associations.
Yeah, it has to be a multiple collaborations. Yes, it has to be multiple collaborations across multiple organizations that are sharing information and can. And again, the legal part is very difficult. It's very difficult to press legal proceedings on a foreign entity. It's just very difficult.
Yeah, that's an assignment that we have to cover over the next few years.
Yes.
Questions. Okay, some other vendors, large vendors like Cisco and others, they have offer deception and concealment technology. And what's the competitive advantage versus this type of solutions from Attivo?
So while there are other big players that offer deception as a feature, we offer deception as a platform, right? So our technology is more sophisticated and more advanced than anything the large vendors have. What a lot of the large vendors have done is they've either grown their own, they've made their own deception offering, or they've bought a smaller player and made it part of their deception functions. For example, Fidelis and Fortinet have offered. So Fortinet created their own solution. Fidelis bought a defunct deception vendor and made it their own solution. Where we have the competitive advantage is that we do more, and all of our functions work together to create a full fabric rather than a piecemeal function. Now, would you rather have a feature as part of a much larger thing that you may never use, or would you rather have a solution that covers multiple different layers of your network across multiple different solutions, all doing and working together to give you a cohesive solution? That's where we feel our competitive advantage is. They offer a feature, we offer a full functional and very robust platform.
Okay, thank you so much, Joseph. Nuestra audiencia, muchísimas gracias por sus preguntas. Se nos fue el tiempo, time is up. Por favor, recuerden, aquí a la derecha de la plataforma hay una pequeña encuesta. Háganos llegar sus comentarios, díganos qué les pareció esta conferencia, qué temas quieren ver, a quién quieren que traigamos y que invitemos. Así que los estaremos leyendo, los estaremos escuchando. Muchísimas gracias a todos por hacerse presente una vez más en nuestra web series de InfoSecurity México. Joseph, thank you so much for being with us. It was a very, very interesting conversation with you, and hopefully we can see you again.
Yes, thank you very much for having me. I appreciate it.
One last advice for our audience out there.
Yes. Attivo may not be the only solution out there, but it is acknowledged as the best one. And as we progress in this year, you're going to see a lot of new things as we shift from just doing detection to doing identity across on the endpoint, on the domain, and within the cloud. So be on the lookout for some of the new features and functions and products that we're going to be offering. And stay safe out there.
Absolutely. Thank you so much. Then again, nos vemos muy pronto en un nuevo capítulo de nuestros web series de InfoSecurity México. Muchas gracias a todo el equipo de Read Exhibitions por hacer esto posible y por supuesto a ustedes, nuestra audiencia que siempre nos acompaña. Hasta la próxima. Chao, chao.
Thank you. Bye.